So, hello and welcome back. We were doing the operating system. We have completed already the unit 1 and unit 2, wherein we have talked about the basic of the operating system, its architecture, its types, and its functioning. Also, we have seen the process control block, and the CPU scheduling and the different techniques or the algorithm that is used in the CPU scheduling. So now we will be moving on to another important topic in the operating system that is known as the synchronization and the deadlock. Synchronization and deadlock and deadlock. But before we proceed further, let me introduce you to the Telegram channel, which is available on the URL t.me/apdcio2025, wherein I'm going to upload the lectures note of this video. So do check out that channel. And now let us move forward with the rest part of the operating system. So we have understood that there are different resources that a process may use during its execution. And what is the difference between the program and a process we have also seen in the previous video. So moving forward, let us assume that there is a process P1 and there is a process P2, and both this process is now executing simultaneously. And whenever we talk about the synchronization and deadlock, so we say that this situation will arise when, obviously, if there is a multiprocessor system, means a processor is capable of processing both P1 and P2 simultaneously, then only this situation will arise. Okay. Otherwise, if you are executing one by one, then there would be no such synchronization and deadlock. So this synchronization and deadlock will only arrive if there is a multi-programming system and there are different processes which are running concurrently. So if P1 and P2 are running and these two are let me first tell you or introduce you the difference between the synchronization and what is deadlock. Then we will go on to see what are the different solutions we have to avoid this. So we were that I was saying that P1 and P2 are running. These two are now running. The status is that these two are running. Now, at any instant of time, say T is equal to T1 of their execution, they are now sharing some resource. Resource like it could be any resource, a memory or a drive or something else. So these two are sharing the same resource. It is possible a resource could be shared. Yes, so now, simultaneously, if these two are sharing a resource, so it may be, there is a high possibility that if both the process are sharing a resource simultaneously at the same instant of time, then the output could be unexpected or it could be inconsistent. Okay. So to avoid that, or avoid such scenario, what we ensure that synchronization is achieved between these two processes. Synchronization is achieved between these two processes. Okay, we have understood what is the problem. So why we required the synchronization? So that the result is not inconsistent or unexpected, or the output of the process is not inconsistent or unexpected. Okay, so there could be like the what could be the uh, what could be the possible scenario? I have already once explained. Now there is another important term which is known as the critical section problem. Critical section problem. Critical section problem. What is that? Understand that, then we'll move on to theory part, and then we'll see what is there in the theoretical part. The critical section problem, or CSP, is a problem, or we can say that it is a like the part of the code, since P1 and P2 are process, but these are basically some codes which the processor is executing. So suppose in P1 and P2 we have some part of the code which I know, let's suppose line L1 and here line L6. Good, line L1 is I've written some part of the code, and in L6 I've written some part of the code, and I know the that L1 will be requiring some resource, or rather say the shared resource. Okay. And L6, when L6 will be executed, it will also require the shared resource. So this L1 is called the critical section and L6 is called the critical section. Okay, that is the part of the code which means access the shared resource is called the critical section. Now, what should be the job of in synchronization? What should be the job of the processor? Job of the processor should be that both the process should not be the critical should one process should be allowed in the critical section at one time. Critical section, when I say critical section, it means that the part of the code is basically accessing the shared resource. So at any instant of time, only one process should be allowed to be in its critical section. Okay. I hope you understand that. So let us move to the theoretical part and let us continue with that. So we have process synchronization, which is possible in a multi-programming system while multiple processes run concurrently. And the problem is that if two processes access the same data at the same time, the result may be unexpected or inconsistent. The solution is we have to ensure this synchronization mechanism. And how we will ensure, we'll see it in a little while. But before that, see what is a critical section. Critical section is basically a part of a code where a process access a shared resource. I've already explained this in below lines. Only one process should be allowed in the critical section at a time. The good solution would be that mutual exclusion, that is, only one process should be in the critical section. If critical section is free, one waiting process must give it, and no process should wait forever. That is, there should not be any bounded waiting. So I've already explained that what is a critical section, and you should ensure that the one process should be in the critical section at the time. And also, if the critical section is vacant, means that part of the code that is to be executed, which required the access of the shared resource. If you are keeping the process waiting, that should be allow access to the critical section if there is no critical section. If the critical section is like free. Okay. So what could be the different synchronization mechanism? It could be like it could be like software based solution or a hardware based solution. In the software based solution, we have what call as the Peterson algorithm. What is Peterson algorithm? Let me explain you. Peterson algorithm means basically it is a flag oriented. Each process which want to access a shared resource will be given a flag. The process which is having the flag, there is a flag F. If you want to access the shared resource, only the process having the flag will access it. So suppose if P1 first want to access the shared resource, it will give in the flag F. If P2 want the same shared resource, it will have to wait for the flag to get free from P1, then it can access the same shared resource. So this is what known as the Peterson algorithm. Just remember the name; it is very important. Peterson algorithm. Okay. Then hardware solution. Just remember two things. We can do two things in it. One is called test and swap, and another is test and set, and another is known as the swap instruction. Then there is a semaphores. Semaphores are important. Let me explain it to you. What is semaphores? In semaphores, we are using two atomic operation. One is called wait S and another is called signal S. There are two atomic operation in semaphores. What is atomic operation? Let me first explain you that. What is atomic operation? Atomic operation simply means the operation which cannot be interrupted. Once it is started, it cannot be interrupted. This is the atomic operation. What is semaphores? Semaphores, in order to ensure synchronization, it uses an integer, say S. S is an integer. So if it is counting, so we can say that it is a count. It is a counting. So before counting, let us understand what actually semaphores is. So it is having two atomic operation. One is wait and one is signal S. So suppose if S is like a process will run. A process will run when S is greater than 0. A process will run when S is greater than 0. So in wait, what it will do? It will try to hold the process. So it will set S as S minus 1. So whenever S will become less than 0, the process will be in waiting state. So in wait operation, what we do? We try to decrease S with S minus 1. Okay. And this is known as decrease S. And this operation is also known as P or down. What is it known as? P or down. In P or down, what we do? We do S as S minus 1. The second operation is atomic operation is signal. In signal, what we do? We increase S. Suppose for any process S is less than 0. So it is in the waiting. So you don't want that the process to be kept waiting for a longer period of time. So you want to increase S so that it become greater than 0. So each time you are increasing S by 1, so there will be a moment when S will become greater than 0 and the process will start execution again. So it will increase, we increase what? We increase S, and this is also known as wakes waiting process, basically used for waking of waiting process. Okay, you getting the point now? So this is also known as down. This is also known as up. The above one was known as down. This is also known as up or V. So in semaphores, there are two process. One is called, there is two atomic operation. One is called the waiting, and another is called the signal S. When S is any integer, which is used to control the like the access or control the access of a process or the flow of a process. So in wait, we actually decrease S, and it is also known as P or down. And what we have as S as S minus 1. And when S is greater than 0, the process will run, and when S become less than 0, it will wait. For its signal is also known as up or V, and in signal it is basically used to wake up the waiting process where we do what? S को increase करते हैं by S plus 1. Okay, this is called semaphores. Now, if semaphores is counting, like S is taking value 0, 1, 2, 3, 4, then we call it as counting semaphores. Okay. And if semaphores only take 0 and 1, that means 1 means active and running process and 0 means the waiting process, then it is known as what? Binary semaphores. Binary semaphores. I hope it is clear to you. So let us move further and let us see. A semaphore is an integer used to control the access. I have discussed about the wait as, signal as, and also we have discussed the binary semaphores and the counting semaphores. Okay. So now we move to deadlock. What is deadlock? See, deadlock, there is a difference in the deadlock and the synchronization. Synchronization, we have seen that what is synchronization. In deadlock, what is a deadlock? Suppose there is two process P1 and P2. P1 and P2 are two processes that are running. And P1 is holding our resource. It is already having one resource R1. And P2 is also holding a resource R2. It is using this resource. Now, suddenly at some time interval, after some time interval, say t is equal to t1, this resource, this process P1 is actually now in want of resource R2. And the process P2 is now in want of resource R1. Okay. For completion of it, execution. Good. That could be a scenario. That could be a possible scenario. Yes. So if process P1 is already having R1 and it is now in requirement of like R2, and this R2 is basically already held by P2. So R2 could not be free because the process P2 is holding it, and process P2 will not release it unless and until it completes its execution. And for the completion of its execution, it requires another resource R1, which is now being held by P1. So in that case, P1 will stop execution, P2 will also stop execution. They will stop and wait. They will be in the waiting status and wait for P1 will wait for R2 to get free, which will never get free because being held up by P2. And P2 will wait for R1 to get free, which again will never get free up because it is being held up by R1. So this situation is known as the deadlock. So see, what are the possible possible scenario that has led to this situation of deadlock is, first we can easily understand that the R1 and R2 resource are non-preemptive. Non-preemptive means first condition. R1 and R2 resource are non-preemptive. That means P1 is not willing to release this resource until it's complete its execution. And P2 is also holding on to a resource which is non-preemptive. Number two is what? Number two could be like hold and wait. Means you are holding a resource and then you are waiting for another resource. This is called as hold and wait. Okay. This is another condition for deadlock. What could be another condition? Mutual exclusion. Obviously, if you had paid a little attention in the synchronization, we have said that the resource is shared. If the resources are shared, they could not be a deadlock. But the resource R2 and R1 are such that it is mutually exclusive and could not be shared with any process. And the last one is what? Circular weight. Circular weight. What is the circular weight? This scenario is called the circular weight. When one is waiting for the resource held by the other. So if these four conditions are satisfied, then deadlock will arrive. And these four conditions are known as what? Kaufman condition. Okay. So now let us see what is deadlock. A deadlock happens when a group of processes are permanently blocked, waiting for resources held by each other. Okay. Won't wait forever, and the such situation is known as deadlock. What are the Kaufman condition? Mutual exclusion, hold and wait, non-preemption, and circular wait that we have already discussed. So first of all, what we would like to do. So first of all, we would like to avoid. We would like to prevent कि deadlock हो ही ना. अगर डेडलॉक हो गया तो क्या करेंगे? तो पहले तो अवॉइड करना है कि डेडलॉक हो ही ना. तो इसके लिए हमारे पास एक एल्गोरिथम है जिसको हम बोलते हैं बैंकर्स एल्गोरिथम. बैंकर्स एल्गोरिथम ना. एंड दिस एल्गोरिथम बेसिकली प्रिवेंट्स द डेडलॉक. फिर भी if anyhow like you reached to the situation of deadlock, then what remedy you have to first you have to detect yes there is a deadlock. Then what you have to do, you have to do recovery. That means we have to kill the resource, kill the process, free the resource, and let the other one, like you have two process. So in one process, either one of the process you have to kill the process in between only, and you have to free the resource held by it so that the other process could complete its execution. So this is called detection and recovery. Okay, detection and recovery. So you have to first prevent deadlock, avoid deadlock. For avoiding, you have one algorithm that is known as the banker's algorithm. And if you cannot do that, or even after so many precautions, deadlock happen, then there is only one solution that what you detect the deadlock, you kill the process and free the resource. Okay. Now there is a difference between starvation and deadlock. What is the difference between starvation and deadlock? See, deadlock is like forever, forever, and for all the process. मतलब दो प्रोसेस है तो दोनों प्रोसेस ही होल्ड पे चलेगा, लेकिन स्टारवेशन में एक ही प्रोसेस होल्ड करता है. कौन सा प्रोसेस? जो लीस्ट प्रायोरिटी वाला होता है. ठीक है. लीस्ट प्रायोरिटी वाला प्रोसेस जो है वो होल्ड करता है. लेकिन डेडलॉक में ऐसा नहीं है. जितने भी प्रोसेस हो, मे बी दो या दो से अधिक प्रोसेस भी डेडलॉक सिचुएशन में जा सकते हैं. दिस इज अ बेसिक डिफरेंस बिटवीन द स्टारवेशन एंड डेडलॉक. ओके. So I hope you have understood the synchronization and the deadlock. So now let us move to the next topic, that is memory management. And the summary of the previous topic is like we have seen what is the critical section, we have seen semaphores, what is deadlock, and what is the starvation. We have seen all this thing. Okay, now we are moving to the memory management. So we have already seen that a process when execution is basically executing some line of codes, and for that it has to fetch data and store data in the memory. So already memory access is required. So therefore the memory management is done by the memory management unit MMU. And what function does it performs? It performs like allocation and deallocation and reallocation of memory. So how memory is allocated? So in computer architecture, you must have read that memory is divided into different blocks. So each process is allotted one block of memory. So this, and when the process is completed, this allocation is revoked. So this is known as the allocation, reallocation, and deallocation. Then we have the protection, sharing, and logical and physical addressing. These are basically the process or the functioning of the that comes within the memory management and basically performed by memory management unit. So allocation, deallocation, reallocation, we have understood. Protection is also very simple to understand. Sharing is also simple. Logical and physical addressing, we will see in a while. Okay. So these are basically the functions within the memory management. So what are the different types of allocation? Let us understand this thing. So they could be like memory allocation. Memory allocation में there could be like number one, contiguous allocation. In contiguous allocation, what we do within this contiguous allocation, what we do, this is the like this. Suppose understand that this is a memory. and it divides into blocks. We divides into blocks, and we assign each block to a process contiguously. First, this block will be assigned, then this block will be assigned, then this block will be assigned. Okay. If this is understood that this is the contiguous allocation, let us now see that within the contiguous allocation there could be two techniques. Number one is called the fixed partitioning, and number two is known as the variable partitioning. Variable partitioning. Okay. So in fixed partitioning, the block size would be fixed. Like suppose I say that 1 MB block, 1 MB block. So each block size would be fixed. Now, what would be the situation in fixed partitioning? Now, suppose that like a process requires P1 requires some space of memory. Since this partition is fixed, so maybe it may only consume this much part of the memory, and this much will be free. Another process may consume only this much part of the memory, and other may be free. Another process may require the entire memory and another block, but another block only a little part is required, because since the memory are divided into the continuous allocation is being done, and the memory space or block space is fixed. So it may have like what wastage of space, memory space in each block. So such situation is known as what? Internal fragmentation. This is internal fragmentation. Okay. This is internal fragmentation. So in contiguous allocation of memory, and that too under the fixed like partition, we have what problem? Internal fragmentation is the problem. Okay. If that is understood, let us move to the another contiguous allocation, that is known as the variable partitioning. So here dynamic allocation is done. Dynamic allocation is done means it is contiguous only, that is one next to another, but the size of the block is decided dynamically. So suppose we have a P1 process which required this much size of block, this will be allocated. In P2 process want this much size of the memory block allocated. P3 required this much size of the block allocated. So suppose such is the allocation, and such is the allocation of the memory blocks. So in this case, there will be like 100% utilization of each block, because only that much memory is allocated that is required by a process. So there could be no any internal fragmentation. There will be no internal fragmentation, but there could be external fragmentation here. What is external fragmentation? Like suppose this is like suppose 5 MB, this is 1 MB, this is 3 MB, this is again 1 MB, this is 2 MB, this is 2 MB, and this is 1 MB. Now suppose this one is freed. This process is freed. So let us empty this one. Okay. Try to understand. Okay. Once you understand, you can solve any numerical on this or any theoretical questions on this. Now this P1 has finished execution, so this is vacant, but this is running. The process is still running, and this is vacant, and this is running, and this is also running. This is vacant, and this is vacant. Now there is like a program P4 arrives or any other CPN arrives which require 8 MB of data. So 8 MB of data, and now it has to be allocated what? Contiguously, one after the another. So here we have, although we have availability of 5 MB here, but no 8 MB is present. We have 3 MB here, but no 8 MB is present next to it. We have 2 MB vacant here, 1 MB vacant here. So we can allocate 5 MB here. Okay. But you see, key, even case, suppose this is also failed, or we do not have any extra spaces, only this is the spaces that is there. So even though there may be a situation, even though we have the like 5, 3, 8 to 10, 11 MB of free spaces, but we are unable to load the process. The process is created, that means it is not yet admitted into the memory. So you want to admit it into the memory, but even though you have 11 MB and the process required only 8 MB, but since in the contiguous memory allocation, no contiguous spaces are free over here, we have scattered free spaces. So we will not be able to load this process. So this problem is known as the external fragmentation. External fragmentation. So I hope you understand the problem of internal fragmentation and external fragmentation. So now let us see what does the notes say about it. So one technique is the contiguous memory allocation. One single block of memory process get one single block of memory. There could be two methods, fixed partitioning, and there is a problem of internal fragmentation. In variable partitioning, there is a problem of external fragmentation. Free space is scattered across the memory that we have seen already. Okay. So internal fragmentation means what? Inside allocated block, there is a free spaces. External fragmentation between free spaces are between blocks. This is the internal free spaces for internal fragmentation, and this is the like free spaces between the blocks. So this is the external fragmentation. Okay. So there is another technique for we have seen that in contiguous there is a problem. So there is another technique which is known as paging. So in paging, what we do, we basically divide a process into small process, and that is known as the page. See, and here we have seen the one of the function of the memory management is logical addressing and the physical addressing. This is what logical and physical addressing is done at this paging. So at paging, what we do, basically we divide a process into small process known as page, and we give it a page number and offset. Then we divide a memory into smaller blocks whose size is same as the page size. Okay, that is known as the frames. So what CPU sees, CPU whenever want to load a process, it see which, and there is a page index. Okay, there is a page table. Basically, there is a page table in which there is a page number written and what frames is available. It is written over there. Again, the page is written and what frame is available. It is written there. So a table is maintained. A table is there in which the detail is maintained, which page having what frames in it. So page offset is used by the MMU to find the memory address. And this conversion, this is basically known as the logical addressing and the physical addressing. Here in paging, we use it. So with the page offset, every page is given a page number and page offset, and this is known as the logical addressing. And with this page offset, the actual address of the frame is calculated, which is known as the physical addressing. Okay. So see, in paging, we have a physical memory which is divided into like fixed size block. And when we say fixed size block, then what could be the problem? Internal fragmentation could be the problem, and that would be like problem here. So before going into that problem, let us see what paging is. So memory is divided into fixed size blocks, and physical memories, that division is known as frame, and logical memories, that means the process is known as the pages. The page tables map pages with frame. It removes external fragmentation, but still has the internal fragmentation. Okay. So whenever a process is to be loaded, it go to the page table and there it check what frames are vacant, and then it see the that the in the table it see what page number is available for the vacant frames, and it's allocate to that pages, it allocate to the process. So no contiguous allocation is required from the table. If table number one is frame number one is vacant, it can assign that value. Frame number three, it can assign that value. So contiguous allocation we are done with. We are using random allocation, but since we have divided the memories into fixed size of frames, then we have the problem, like problem of what? Fixed size frame. We have the problem of internal fragmentation. How? If suppose there is a frame of 1 KB and a process which requires 4100 bytes. That means it required 4 KB plus 100 bytes. So since the size is what? 1 KB. So 4 KB means 4 frames will be used, and in the next frame only 100 bytes will be used. So internally that frame will be vacant. So that is the internal fragmentation problem is there. So another problem, like in the contiguous memory allocation, we have two techniques, fixed and partitioning. So in random also we have two techniques. One is called the paging and another is called the segmentation. In paging, we have seen we have the fixed block size, and therefore there is a problem of what? Internal fragmentation. If you just remember, in segmentation, there is a problem of external fragmentation. I hope that is easy to understand and remember. There is a contiguous memory allocation and then there is a random memory allocation. In contiguous memory allocation, there is two techniques, fixed and partitioning. Fixed suffers with the problem of internal fragmentation, and variable partitioning suffer with the problem of external fragmentation. In random memory allocation also, there is two techniques, one for fixed, which is known as paging, and suffers with the same problem of internal fragmentation, and another is variable called as segmentation, that is for variable partitioning, and that also suffer with the same problem known as external fragmentation. Now there is another technique which is known as the virtual memory technique. In virtual memory, what we do whenever a, like see a process may not have all the pages that that process is loaded. So the instant when the process is loaded, it is possible that it does not have all the pages required in loaded in the main memory. Main memory means the RAM. ठीक है, suppose is required P1, P3, P4. Only only P1, P2, and P3 is loaded in the RAM, not P4. But the process required P1, P3, and P4. So it may happen sometimes that the when the process is loaded, it may have it may not have the pages that is required in the main memory, that is in the RAM. So what has to be done? That page has to be fetched from the the disk or the secondary memory into the main memory. So this is known as what? Page fault. This is very important. Page fault. Last previous question was there on page fault. So what is a page fault? That is when the required page, when a process load and it finds that the required page is not present in the main memory, that is in the RAM, then such situation is known as the page fault. And in that case, that page means what? Memory block only I'm talking about. That page is to be brought from disk into the RAM. So this is page fault. So there is with the page fault, there is another term associated which is known as the thrashing. What is thrashing? Thrashing means when there are large number of page fault occurring, when there are large number of page fault occurring, then in that case, what you have to do? Most of the CPU time will be wasted in bringing out those pages from secondary memory to the main memory. Okay, and such situation is known as the thrashing. That means if too many page faults occur, then instead of execution of the process, the CPU spends more time where swapping of the pages from the secondary memory to the main memory, and therefore the performance would drop. So this is known as the thrashing. And when will thrashing occur? Obviously, when you have large number of process or to be executed, that is when the degree of multi-programming is high. Okay, in that case, thrashing may increase. So let us just quickly finish this. Virtual memory we have seen, disk swap space, demanding paging and page fault. We've seen page fault. Page fault means page is not found in the memory. So page replacement algorithm, this we will better understand when we replacement algorithm when we'll see cache. When we'll see cache, we will understand this better. So leaving it for now, time being. So in memory management, that is in computer architecture, there is cache replacement. Same technique can be used over here that we will see in the later videos. So thrashing we have already done that if too many page faults occur, CPU spend more time swapping the pages than executing and performance drop happens when the degree of multi-programming is too high. Okay, and this is the summary of the thing that we have done above. Fixed partition, variable partition, the problems that is faced, then the paging, there is the solution that is no external fragmentation, but internal fragmentation is there. And in segmentation also, there is division of program and external fragmentation occurs. Virtual memory suffers with what? Page faults and thrashing. Now let us move to the files and input-output management, and we will only cover some of the points in this. See, file basically what? File is any information that is stored in the secondary storage. Any information that is stored in the secondary storage is known as what? File. So there could be different types of operation, basically 7 types of operation that can be performed in the files. And that 7 types of operation are basically what? Create, open, read, write, seek, delete, and close. Okay. Compile is not an operation of file. So only 7 types of operation are there. That is create, open, delete, open, close, read, write, delete, and another is seek. Seek. Seek is or peek is also operation on what? You have stack में operation होता है ना peek. That is the operation. And also in queue. Queue में भी होता है in queue, DQ, and peek. So that is. The file को हम access कैसे कर सकते हैं? There could be 3 techniques. One is called the sequential access. जैसे हम करते थे example in the tape drives. Another could be like direct random access. Direct access उसको random access बोलते हैं, ठीक है? And the next could be the index access. This could be like 3 types of file access: sequential access, direct random access, and the index access. Now let us see the important techniques are just the that are used in the file allocation method. The file allocations may there could be like we have seen already the contiguous allocation could be there. So contiguous allocation will already suffer from external fragmentation. Now here see contiguous allocation. Above we have seen that it could be like of 2 parts, fixed and variable. And fixed parts suffer from internal fragmentation and variable parts suffer from external fragmentation. In file, we have contiguous suffering from what? External fragmentation. Okay. Suffering from external fragmentation. That means your partition is variable. Okay. Partition is variable. There could be like continuous allocation. There could be linked allocation. In continuous allocation, we have the external problem is what? External fragmentation is the problem. In linked allocation, there is another problem that is slow random access. This is the problem in linked association. To solve this problem, that is, you should do not have an external fragmentation and you also do not have slow random access. We use indexed allocation. Indexed allocation is here. So it index allocation solves both random access, slow random access, and what? With fragmentation issue. So which allocation suffers from external fragmentation? That is contiguous. Now moving on to the next, this scheduling algorithm. Just remember the name. When there are, we have see what we have seen in the beginning. We have seen that the operating system का functions क्या है? Input type, input output management. Then we have seen the file management. Then we have seen the process management. We have seen the memory management. We have seen the security and protection, and we have seen the resource allocation. These were the six functions. Out of this, we have seen the process management, we have seen the memory management, we have seen the file management. Now, let us go to the IO management. So, in the input output management, if there are too many input output requests coming to the CPU, it will how it will see like for the CPU when there could be large number of processes to be executed. P1, P2, P3, and there we use the CPU scheduling technique. So if there are multiple processes that is to be executed, there could be multiple input output requests initiated by each process. So in that case, if there is a multiple input output request, how do we schedule it? So in this technique is known as disk scheduling. This scheduling. This technique is what called as disk scheduling, and there could be like four techniques, four widely used technique. One is called the first come first serve. We have already seen that. Shortest seek time first. Now, what is seek time and what is like the how do the memory read and how what is known as the seek time? That we will do all this thing in the computer architecture when we'll read about the memory management there. But you just remember the name. That is where do we require the disk scheduling algorithms? We require it when we have like large number of input output services or input output requests to be handled. So in that case, one is the first come first serve. Those input output those IO requests which come first will be served first, or could be the shortest seek time first. Those who will require the shortest time to be completed will given the priority. Or it can be scan. The scan we have the elevator algorithm. What is elevator algorithm? That okay, ठीक है. What we will do? It's just like the round robin. We'll go on from P1 IO1 request, I2 request, I3 request. In this direction, we will go on handling the request and then we'll again come back in the opposite direction. So it just functions like lift. It will go on addressing the request. Again, it will come down addressing the request. Again, it will go up addressing the request. It will come down addressing the request. Just like the lift. Therefore, it's called as elevator algorithm. And there could be the circular scan. Circular scan means so that it's handle the request only in one direction. Only services in one direction. That means will go up. Again, it come back to the bottom point. Again, go up. Again, come back to the bottom point. Again, go up acknowledging the request one by one. So this is called the circular scan. So these are the different type of this scheduling algorithm that we have seen. Now, in the IO management, we have three techniques. In the input output management, there are three techniques. That is, one is called the buffering, another is called the caching, and one is called the spooling. Three technique means what? Okay, IO management means what? Also, you have to synchronize the data being transferred between the input output device and the internal CPU or the memory. For that case, that this is also known as the management, IO management. And for that case, you have buffering. Means if the like you are able to transfer the data at a variable speed, like at a high speed from the internal, but the input output device does not be able to process the data at that space. That means you are sending from within the system large number of data. Only a small portion is getting handled by IO at that particular instant of time. So a large chunk of data will be like build up that is to be processed by the IO. So this build up is used in a space known as the buffering size. So buffering size is basically maintain what? Synchronization between the input and the external, like input output device and the internal device. Okay. This is called the buffering. Another could be caching. Another could be spooling. So now spooling is a technique which is used in the for the printer output that you should remember. Spooling is a technique that we use in the printer output. So for input output management, first, if there could be a large number of requests that could be done by the disk scheduling algorithm. And for input output management, we could have three techniques. One is called the buffering, another is called the caching, and the third is called the spooling. And spooling is the technique that we used in what? In printer. The summary is that access method where we have the sequential file access method. How do we access it? Sequentially, directly, or randomly, or index size. Allocation of file, we done it like in contiguous and length or in index method. Index method where we have seen that the contiguous where we have external fragmentation, and linked. What is the issue we are having? We are having the slow random access, and this is the best because it solved both the previous problems. Then we have the disk scheduling and input-output management technique, that is buffering, spooling, and caching. Okay. If this is done, let us move to the last topic, that is security. First of all, understand security is a separate topic in this exam, so you have to do it very have to spend a lot of time in it. But from the point of the operating system, let us see only 2 points that are very important in it. One is the CIA triad is there. CIA, what is the CIA triad? CIA triad means the one is called the confidentiality, A is for the availability, and I is about the integrity of the system. So this is confidentiality. This is called the integrity, and this is called the availability. That is, whenever you want the resource, it should be available. These are the three triad of the security. Now, what is the difference between the security and the protection? What is the difference between it? See, security means there is a two terms, security, and there is another term called as the protection. The security basically means what? To prevent unauthorized access. अनऑथराइज एक्सेस तो उसके लिए आपके पास टू टोकन बेस्ड ऑथराइजेशन है पासवर्ड है लाइक दैट यू थिंग्स यू हैव एंड प्रोटेक्शन मींस व्हाट not allowing not allowing resources not meant for a user. आप authorized user हो but you will be not able to use a resource if it is not meant for you, not meant for a user. That is called the protection, to protect a particular resource from getting used by every user. Okay. So, yes. So, like, see, there could be resources. There could be three methods or three techniques which we can, for in the protection mechanism, we say in the protection mechanism, there could be three techniques. What could be three techniques? Number one, it could be like max access matrix. Access matrix. In access matrix, we have rows and column. In rows, what we have? We have subjects. In rows, we have subject, which is called as the users. And in column, what we have? In column, we have objects that we call as the resource or process. Sorry, resources. That is called as the resources. And subject is users or process. Okay. So in row, we have what? In row, we have the user or process, and in column, we have the resources. So suppose we have resource R1 printer, R2 microphone, R3 camera, and we have user U1, or suppose process P1, process P2, or user Q2. Okay, this is what we have. So this is the matrix. There could be another user, but let us for simplicity understand with only two users. So suppose it is having a write for this resource for user R1 is only have write access and read access and write access. No delete access is there. For resource R2, no access is there. For resource R3, only delete access is there. Okay. Similarly, all the access or authority is being written here also. Suppose read, write, delete. So in the matrix form, we are able to see the complete details, which users are having access to which resource and which resources are restricted to which users. So this is known as the access matrix. What are the disadvantages to it? The disadvantages it is having a large data set which is to be stored. Okay. And also the user having no any authorization, even though this information is available. Although it is a detailed information, it is good, but the memory usage is no. So another type of protection mechanism we have, and that mechanism is known as the access control list. In access control list, it is basically list of the objects. What do you mean by the list of the objects? Say suppose objects are what? Objects are resources. Suppose we have R1, R2, and R3. These are the three resources. So we say that which are the users who has access to use this resource. Okay. Suppose we say U1 is you can use this, U2 can use this. So R1 resource will only be shared with U1 and U2. This is another method of like managing the access. So this is called what? Access control. It is with respect to the object. Okay. It is with respect to the object. Each object is having the list of users which can access them. Another technique is known as the capability list. Capability list. And this technique is just opposite of the ACL. Here we have subject-based list. Subject-based list means any user U1 or any process P1, what resources can it use? Say R1, R2, R3. These three resources can be used by user U1 or process P1. So each process or user has the list of objects. And objects I already told what resources are known as objects. So list of objects it can access. So this is known as the capability list. Capability list which simply means what are the capability of the users? What resource can it use? So it is subject based list and ACL is an object based list. So, guys, with this, we come to an end to the operating system. For recapitulation, I will just state what the things we have covered. Like, we have covered the basic with respect to the operating system. We have covered the process and entire detail with respect to the process. We have done the CPU scheduling and different algorithm. What are the advantages, disadvantages we have seen. Then we went to memory management. There we see the problem associated with the contiguous fixed size allocation, contiguous variable size allocation, paging, segmentation, page fault, thrashing. All this we have seen. Then we have moved to the input-output management, where we have seen three techniques. That is buffering, caching, and spooling. The spooling technique being used in printer. Then we have seen the this scheduling algorithm, that is the circular scan, which is like depending upon the elevator algorithm, and the other two technique, that is first come first serve and shortest seek time first. And then we have also seen the file allocation system and the different operations that file can be performed on the file. So this is all in the operating system that we have to do. So I think you have understood this chapter. So okay, let us meet in the next video and we will see try to cover the another topics. Okay, thank you.